and welcome to our channel Link Frequency, and I'm Aishwarya Pattar. Today's video is going to be very special on our course, that is Artificial Intelligence for Absolute Beginners. We are going to discuss about the future of AI, that is reinforcement learning. We will talk about what exactly reinforcement learning is and also the workflow involved in this method. Then we will move ahead with understanding the positive feedback and negative feedback of reinforcement learning method. Then we will look into the merits and demerits of this method. Lastly, we will conclude with the challenges that are faced if we are trying to opt this reinforcement learning method. Without any further delay, let's get started. Alright, the screen might be visible, which indicates reinforcement learning. We will try to understand this reinforcement learning step by step. We will begin with the introduction part. Well, reinforcement learning is a subcategory of machine learning. Here, basically it is all about the agent trying to observe the environment and then take some action. In return to this action, it receives a reward. The reward can be either positive or negative. So overall, it tries to do some trial and error and learn from its experiences. So the same thing has been indicated here. Allows learning system to observe the environment and learn ideal behavior. So based on its observation and actions taken, the machine or the agent is going to learn. It learns by trial and error, that is feedback based system. So here basically the action which is taken by the agent, it receives a reward. That reward is being indicated either positive or negative. So this feedback system will help the agent to go through the process so that it understands the system much better, take suitable action to maximize reward in a particular situation. So this point, it indicates that the main aim or the objective of this agent is to have a best possible solution, and that best possible solution comes with a maximum reward. So its main goal is to collect maximum reward by taking best decisions. So this is all about the introduction part that is involved in this reinforcement learning. So let's understand this concept of reinforcement learning. So there is an agent and an environment. So what happens is the agent will try to observe the environment and environmental situations. Then based on the situations, it is going to take some action. Alright. So this action will be taken by the agent with the environmental conditions. Then what happens is, in return to this action, the environment is going to give a feedback, that is, it will assign a state and also give a reward to the agent. So the reward can be something like a positive reward or a negative reward based on the output which has been desired or which has been expected by the system. So this is what happens in a loop, so that the agent tries to learn from its mistakes, and again based on the mistakes whichever is been created the previous time, it will try to avoid it in the future. So this is what happens in reinforcement learning method. So if you notice here, there is no data set which is given with the labeled data. So it is all by the agent and by its experience it is trying to learn. So now let us understand the terminologies in a better way. So firstly, input. So input is something that we provided to the initial stage for the model to start. So that is the initial input we are providing. Then we will move on to the output. Here, since the action can be anything, like the approach can be anything by the agent, so the output varies in a variety or multiple forms. But ultimate result or the end goal is the same. So the approach taken by the agent can vary in a various formats. Then what happens is training. So in training, based on the input, the training is given. Alright, the model then tries to give a state to that agent, and also it will try to give a reward to the agent. So reward is based on a positive or a negative impact. We will explain it in a detail in the upcoming few more topics are there. I'll try to explain it in depth. So at present, just remember there is a positive reward and a negative reward. Yeah, so this is part of training. Then learning. So learning happens continuously till a best solution is achieved by the model. So there is a loop. If you see, the action is taken based on the environmental conditions and then it gets a feedback. So based on the feedback, it tries to improve and then again takes up the next action. So this loop goes on till it gets a best possible solution for that particular problem. So this was all about learning. Then lastly, maximum reward. So the best solution is considered when it gets a maximum reward. So this is a long-term goal which the agent tries to achieve. To fetch a best solution, it tries to get maximum reward in all the possible actions it is trying to get. So this was all about the workflow that was involved in reinforcement learning method. So now let's move ahead. Since I told that there were two types, that is a positive reward and the negative reward, let's understand these two types of reinforcement learning. Alright, to explain it in more brief, let me explain with an example. Okay, consider you have a car. Alright, and consider it as a self-driving car. So the car, it starts moving on the road. Then suddenly it sees an obstacle. So what is expected by the car is to slightly move aside and take a different path, so that it doesn't have to hit or smash the obstacle. So if at all the car does that, then it will get a positive reward, because the expected thing was it shouldn't hit the obstacle. So that becomes a positive reward which the driverless car is going to get. But what if consider a situation where the car hits the obstacle? So this is not expected, or this is not the outcome which is desired. So in that situation, it will get a negative reward. So this feedback will help the system to understand, and also it will not try to do the same mistake again. So based on its past experiences, it is going to try to learn. One more example I can give is, consider there is a fire, and there is a person A, and he has never seen fire in his life ever before. Then what he does is he just goes and touches that fire. So after touching that fire, he will have that sense of pain. So that will be fed into the system that this is a dangerous thing and this I shouldn't be doing. So next time whenever the person sees the fire, he will avoid touching that, because he already knows from his previous experience that this is what he shouldn't be doing. So this is what even the agent tries to do in real time. So it is actually trying to mimic the human behavior, like how we are trying to learn. Even the agent is going to trying to learn on its own. So this is one more example which can be very feasible to give at this point of time. Even that occurs due to specific behavior. Increase the strength and frequency of the behavior. So positive rewards, whenever you get, you try to do that over repeatedly again and again. So that is part of the agent also. So it tries to do that kind of activities over again and again, and it gets a maximum reward points. Then coming to negative, behavior that occurs due to negative condition which should have been stopped or avoided. Yeah, as in case of that car, if there was an obstacle, it shouldn't have hit that obstacle. So that condition should have been avoided. So if at all it doesn't avoid that situation, then it becomes a negative reinforcement learning reward. So it can be a kind of a penalty for that agent. So this was part of types of reinforcement learning. So now let us move ahead and try to understand what are the merits of using this approach. First and foremost thing would be solving intense complex problems. Here what it is trying to indicate is, whenever the problem is huge or big enough and it requires a lot of data to solve that solution, to solve that particular problem, then you can use this reinforcement learning. This doesn't require large label data sets. Yeah, as I was showing you the workflow, I told that there is no requirement of label data set which is the agent is trying to get. It is trying to learn on its own based on its experiences. So this approach doesn't require any label data set. So that is the major big advantage, because as and when the technology is progressing, that there would be huge amount of data, and labeling that data would be an extensive process. So that is been avoided by this approach. Bias resistance and goal oriented. Bias resistance is something like, for example, consider you were doing supervised learning method and you were trying to label the data. By labeling, you try to, there might be some bias in the data. What happens? The model will learn that biased data itself. So that would be a problematic situation, or you wouldn't get a desired model at the end of the day. So here in this particular condition, what happens is, since the agent is going to learn on its own, there would be bias resistance. Like there wouldn't be any bias in the system, because it is trying to learn on its own, and also it will create some new patterns or new understandings which were not even thought by humans. So that would be a major advantage. And goal oriented. So for example, to be specific, there were so many robots which would only play saucer or which would only walk. So these kind of agents you can use to perform a specific task or a specific goal-oriented activity. So that they become perfect in that, and eventually you can use them to automate your process and all. So this becomes a major advantage of using RL method. Own experience without human intervention. Yeah, since the agent is trying to mimic how exactly humans are trying to perform their activity, so there is no requirement of pre-programming that agent to achieve long-term results. Yeah, so as I told in the initial stage itself, the main objective of these kind of RL method is that over the long period of time, it wants to achieve a best solution with a maximum reward points. So these kind of approaches you can see in the gaming systems. For example, there are so many games which will give you levels. So if you cross the level 1, you go for the level 2. These are kind of states, and reward is something that you get in points. So based on the action whichever you are tracking in the game, like action can be something like moving right or left. For example, you could have seen it in Counter-Strike. Right? Based on your action, you move to the next level and you are rewarded with the points also. So a similar thing happens in various other applications of. So now let us understand what are the demerits of using this approach. Okay, the first demerit is requires a lot of data and computation time. Yeah, since the agent is going to try to understand and observe the environment and then take action, and then based on the action it gets a feedback, right? So this process has to go on for multiple times so that the agent becomes perfect enough so that it recognizes what its responsibility is. So this requires a lot of data and it requires a lot of time, which is very important aspect to consider over here. Preferable for solving simple problems. Yeah, since there is a lot of computation of time involved, you cannot use this method for simple problems, which can be either solved by any of the supervised or unsupervised methods. You can use those rather than using this method. Lead to an overload of state which can diminish the results. Since the agent is going to work on a loop system based on the feedback, what happens is if the feedback every time it receives the same state, then what happens, the results which has been expected can reduce the overall optimization of that result can be reduced based on overloading of the states. So this is one of the demerit which you can see by using this approach. Pairing a robot costs a lot and requires careful maintenance. Yeah, since the agent can be anything, right? Agent can be a moving robot or any system. So what happens is, since there would be a wear and tear of parts in that robot, so you have to have some maintenance for that robot. Whenever the maintenance is involved, and there involves a cost also, since these are high-end machines, so cost involved is also similarly on a higher side. This all were the demerits which I could foresee by using this approach. Then lastly, we will talk about the challenges of using RL approach. First challenge would be lead to an overload of state which can diminish the results. So overload would be the major point of concern for us, since the actions are anything, like actions can be anything which can be taken by the agent, right? And actions, if it happens repetitively, the same actions are taken, then there would be for sure overload. So in that situation, the results may or may not be to the desired extent. Second would be reward design should be involved in this process. So here, after the action is taken, the agent would be waiting for the response or the reward. It would be waiting for the reward to be collected. Based on the reward, it will judge whether it has to approach in the same format or it has to avoid that format. So this becomes a mandatory point whenever you are using this approach. Different parameters may affect the speed of the learning. So here, there are certain other parameters whenever you are trying to use this approach. So if these parameters are affecting the agent, then the speed of learning for that agent also will be reduced. And there are various environmental factors also which can reduce the speed of learning rate of the agent. RL agent needs extensive experience. Yeah, and this extensive experience is only got when it has a lot of trial and error and when it tries to learn a lot of things on its own. So it requires a lot of time to learn to that extent. So these are the basic challenges which might be faced whenever we are trying to use this reinforcement learning approach. So alright, we discussed more or less more about reinforcement learning. So if there is any questions from your side, you can surely drop in the comment section below. Thank you so much for watching our video. If you like the video, then share it with your friends and all the machine learning enthusiasts. Tune yourself to make a difference.